Next, I'd like to look at an example of inverse variation. So we know that if a problem talks about something being directly proportional or varies directly, that we use the direct variation formula y equals kx. But you'll also see problems where it says that something is inversely proportional, or you might see that it says it varies inversely. And so if we see that, we're going to use the inverse variation formula, which is y equals k over x. So we're looking for that key phrase, varies inversely or is inversely proportional. And whatever the first thing is that varies inversely as the second thing determines what we'll put in the place of y and x. So for example, if we said that r varies inversely as d, then we would write r equals k over d. So that varies inversely tells us what formula to use. The first thing went in the place of y, which was r. The second thing, d, went in the place of x. So let's look at an example that does this. So this says the intensity of light I varies inversely with the square of the distance d from the bulb. And there's a period here, so I'm going to stop just with that first sentence and see what information I can come up with from what I've read so far. So I am seeing a key phrase. I'm seeing varies inversely. So I know I'm going to use the formula y equals k over x. However, instead of y, I would be using the first thing they mentioned, which is I, or intensity. And instead of x, I'm going to use, so if I read this very carefully, it says it varies inversely with the square of the distance d. So that means this is not going to be I equals k over d, but actually it's going to be, in this case, I equals k over d squared. And normally in my inverse variation, I would not necessarily have a square there. It's because they mentioned that here. They say it varies inversely with the square of the distance. If it had said that it just varies inversely with the distance, then it would just be I equals k over d. All right, so just from the first sentence, I can gather that information. I'm going to keep reading. So it says, if a distance of 2 meters creates an intensity of 3/4 foot candles, and there's a comma there, so I'm going to just stop and see what can I come up with just from that part. So a lot of times you'll see problems like this where you don't necessarily understand what they're talking about. So unless you're already really familiar with intensity and things like that and how it relates to distance, then this may look really foreign, like foot candles. What in the world is a foot candle, right? You don't have to know that, right? Don't get too thrown off by unknown terms like this. In this case, foot candles, it's just a unit of measure, right? If you really want to know what foot candles is, it has to do with how many feet away you can still see the light of a candle. So it kind of an old-fashioned term that we still use today, kind of like horsepower originally means how many horses it takes to go a certain distance in a certain amount of time. So don't worry about it in terms of what it is, you're just going to use it. So we're just going to plug in some numbers here. It says if a distance of 2 meters creates an intensity of 3/4 foot candles. So that information is telling me that 2 meters, I can plug that in, and that's a distance. So I could plug in 2 in the place of D. And then they're telling me that the intensity is 3/4 foot candles, but I won't worry about that for right now. So I've got 3/4 equals k over 2 squared, and that's enough information to solve this equation for k. So I could say 3/4 equals k over 4, since 2 squared is 4. And then you have several choices here on how you want to solve this. So one thing you can do in this situation when you've got two fractions equal to each other is you could actually cross multiply. And that's one way to do it. So if you did it that way, you would get 3 times 4 is 12, and then 4 times k would be 4k, and then you divide both sides by 4, and you get k equals 3. So that's one way to do it. Another choice there in terms of solving this, since we are dividing by 4 here, if I want to get rid of division by 4, the opposite of that would be to multiply by 4. So I would multiply by 4 on both the left and right side of my equation. And then the division by 4 and the multiplication by 4, those are opposite processes. They essentially cancel. And so then that would just leave me with k equals 3. So it's another way that you can approach this. And then one more way, and it really only works on this one, but if you look at what it's saying at this step, it's saying that 3/4 equals something over 4. So if you just look at that, like if we're saying that this is something over 4 and it's equal to 3/4, well, that something has to be 3. So honestly, you could just look at it and come up with k equals 3. So that's my value for k. And as long as you're comfortable with one of those 3 methods for finding that, then that's perfectly fine, as long as you have one method that you know works for you. So once I have k, I've got the first half of my problem complete. I'm going to rewrite my original equation, and I'm going to plug in that value for k. So I equals k over d squared becomes I equals 3 over d squared. And now I'm ready to read the rest of my problem. So I stopped at the comma. The rest of this says, what is the intensity created when the bulb has a distance of 5 meters? So it's telling me to plug in 5 for the distance, for D, and then I want to use that to find the intensity. So 5 squared, that's 25. And that fraction actually doesn't simplify, so I could just leave it just like that. Since it is a story problem, I want to make sure I put the correct units on this. So this is when I just have to look and see what units did they use. So the units that they used in this problem were meters and foot candles. Meters was for distance. This is an intensity, so this must be in foot candles.